Well, it's sure you're through.
VirtualBox is not working today.
Of course not. Live demos, what do you expect?
Yeah, the first thing was the network started failing. Then I can't copy and paste back.
So you're just having day after day of fun. Excellent. Right. Okay, put that obviously about there. Pop that one in your pocket. Do the same for that one.
Where was this one go?
Next to it.
No, next
It's
to it.
back up microphone set. We're running two because we're recording separately because they lost audio last week. So that just clips the same place. And the other one's not really, check out all of them.
Cool.
You're going forward. Yeah. There we go.
Thank you.
Excellent.
What was your name?
Tom.
Oh, nice to meet you.
TB Sliver. Runtime error. Oh. And then my recorder just completely crashed. Excellent.
Is that visible?
It's very tiny.
Is that visible?
It's still on the timer side.
Yeah.
On the back.
25?
Well, that's not too bad.
Maybe ask questions if people can read.
This is the whole thing. So I think 25 is good. All right. So this worked first time earlier. Let's see if it still has luck. Sweet.
Microphone down 6. That's what went wrong. That crashed. The software crashed.
Really?
All right.
First time it's happened.
And the second one.
Right. Otherwise.
Are you ready?
Okay. All right.
Ready? If you try and stay between the lines there and there,
Okay.
and then you're being shot.
Yeah. All right.
Can you change, one color of the gray to white? Really hard to read.
Is there an easy way to do that? Do you know off the top of your head in console?
Try to turn it off.
No, it's talking about the font. The font color.
It's like a has a picture in there.
What's that? Is it readable enough? Okay. I can see it. The point's not really the code anyway. I hope to actually have an effect occur from this, this little talk. I'll start with background. So my name is James Osborne. I've been involved with computers since about age 6, 1986. I started in Commodore piracy through my cousin. I moved into the BBS world starting in 1990, 1991. Ran a Renegade board for 6 years, all that sort of stuff. The start of this program started in 2002 with a mud mapper. Been a big fan of LP muds for a while. Louder?
Yes.
Okay. I've been a big fan of LP muds for a long time. And so this idea came to me to have sort of an auto mapper creator generator with this up and down and spatial orientation and arbitrary things moving out from this monadic structure. Data structures in general has been the interest of my focus. That's what this is. So in 2008, I moved to Slovenia, started working on a program called Jitterbug, which had a more or less non-existent user base. The idea was a stair-step encryption model, kind of like Tor, but a lot more efficient. You can see up there, possibly the prime I'm using is 257. I'd like to never go above that number. Pretty sure this is good for it. So this is called dysnomia. The idea is to change the way we think about integral mathematics. If you've used Diffie-Hellman and you know what that is, and we can separate Montgomery substitution from what Diffie-Hellman is, then the idea behind Diffie-Hellman is you want to arrive at a common data point without communicating it. So that's the 70s. The best only improvement we've gotten on that since the 70s is Moxie Marlinspike and Trevor Perrin, their open Whisper systems, triple Diffie is what I'm calling it. What they do is you come at this common secret and you actually project through the secret to get common data points on either side, so you can perform a handshake and you actually have one of two peers is over the other, which is a big deal. And then in their case, they take that handshake and they make an SHA hash of it, and they use this much more significantly complicated hash to do your communication. So instead of with Diffie-Hellman, you have this common data point that a man in the middle can actually observe the interaction that went on to get that data point. With Open Whisper's model, you have your handshake going on, and by the time you get to the end, this SHA hash is built from things that are more or less impossible for you to get in any type of reasonable time, which is great if all you want to do is communicate your secret to someone. If we think about Diffie-Hellman and what it is to have this shared secret, what is that first shared secret? So what I'd like to do today is break the nuclear industry, because that's what it is. So I think I can draw on this. Oh no. Microsoft hates us all. Okay. Trash. Screen sketch. Okay. So if we have our initial A and B peers, and each one of these guys has a secret, and we have this dialogue that goes on between them, and then they have a common path through the dialogue where they arrive at their shared secret. The Open Whisper extension adds these three extra guys. They don't give them very good names because they didn't figure out the math on this, but use these guys to make your little handshake. And then down here, you end up with a completely new object. So you can see how the man in the middle, obviously they can see that first one. They're not going to see the second one. When we think about what this is here and what's happened with this handshake, we have this peer B who's come down here as an active listener and is receiving the handshake. Peer A goes straight past that, and we have essentially, what is it, the Heisenberg uncertainty. So by that point, we're at, I think, 6 integrations, if we think of calculus. So I'll pause here and introduce a mathematician. If you're Italian, you might have heard of him. Otherwise, maybe not. Cesare Arzilla, who taught at University of Bologna starting in about 1880. So his theorem, if I get out of that one, we have limit of I over phi to the n greater than or equal I u. So what that means is the limit of what I can do with my tools is going to be, in general, greater than the limit of what I can do with this other person, assuming that I'm not defining this other person as a tool. We have a conditional where we actually define I of phi n equal to I of u, or phi n equals u, which is called the Bolzano-Weierstrass conditional. So if any of you have ever worked at Microsoft and you have the social employees who have jumped onto Azure and they have their job defined and they do their job, they don't get anything done, but they earn a paycheck and do what they're told. Not really interested in that. Cesar Arzilla's topography, we can take, let's see, so integral from 0 to 1, so across, say, a sine function of e to the x, y, which we'll say is our input functor. So we have, in general, we're thinking as a dynamo. We have our x and y, and our e function is what we put through that. So exy, gy, dy. So that theoretically, if we have a perfect phi n, we can solve all dynamic functions with our one-dimensional starting point where we went through like that. It's not a Greek letter, but it's good for this. If we go from this, and we get absolute f of x minus f of, also not a Greek letter, is less than or equal to our integral from 0 to 1 of absolute gy times our e to the xy from before, minus e to the, not a Greek letter, y, absolute dy. We essentially have our convergence of absolute ability to provide for the given challenge. So to move on from that, what I'd like to do, in order to break the nuclear industry, we have down here on this guy, come on, our reactor. So what I did just before the start of this, I will argue, is ran a nuclear test. How do we prove that? We have the NQA1 audit. We have squeeze the cans. So we can essentially say there's either a true datum or there's not a true datum. If we perform the nuclear test, and essentially this code's out there, it's good. This version is suitable for data container, for everything a computer can do, as is. There's a version in Python that goes 10 integrations more. It's not entirely correct, as this little ring guy right here. So if we think about what we're doing when we go through this psi function. We have our secrets up here. We have our signal here. That's that one. Our channel becomes this guy out here. The pole is the three-dimensional container of that object. Our identity is essentially coloring all that guy in. Our foundation now, since it's flat, we actually have a plank if we perform that math correctly. From that plank, if you think about what a wire is, like when you use your modem, how does your modem or your NIC or whatever it is, how does it communicate to the other side? So you have this spot in the middle and it goes up and down. It's not nuclear when it's a modem, but when we're operating off of the nothing, it absolutely is. So this foundation looks like a plank. The math says it's a triangle. If we want to look at the automotive industry, we have ethylene dibromide, which is a double triangle. We don't want that. So we have a non-zwitterionic foundational element here, which is how we define element, because it's non-zwitterionic. Our dynamo is the fact that we have two entry points to it that have full control over the shared secret without having communicated anything about this common element. If we look at that and we say, well, we have a foundation and an element now, and we have our dynamo, which is defined by the fact that it is tied to an element. If we ring into this guy, we get our reverberations out. And so we have essentially modem, board, plank, ring. What the ring actually is, we have one for each of these guys, and they are common but not the same. And this part is suitable for common functions today. I've already got the next version ready to go, which has 4 rings, 8 rings instead of 2. So what is the nuclear barn? If you're wanting to do the nuclear operation, essentially you can think of the barn as like the membrane. And once you cross that membrane, you're in uranium space. So it's arbitrarily far away, even though you may be able to hold it in your hand. It's arbitrarily far away. That's why there's radiation. So if we get from the ring action on this, we get literally exactly what the Fukushima reactor was. It didn't succeed. So theoretically, this doesn't succeed either. But we have an absolute definition of these as alpha particles, which nothing in the nuclear industry has today. And I'd like to argue that that's absolutely not okay. So, what can you do with this guy as is? I would like to argue, to Donald Knuth specifically, that you can't build a better hash function. Just throw that out there. I'd like to argue not with this version, but with the Python version, that you can't do RSA better. I don't yet have AES because I haven't completely figured out encryption, which requires some Bernoulli math, which whoever wants to get that would be awesome. Yeah, so as of this moment, are any of you Scientologists? No Scientologists in the room. So Scientology, I'd like to say that what I'm trying to do here is a balance of what Scientology is and what Sharia law actually is. So the argument is we've defined a certain number of words. If these words are defined better than what's in the listener, then it will ring true from this location, and it won't ring true from the former location. Sharia law is essentially the same thing. So if we think about what apostasy is, so I, as a person, let's say I cross a line here and I've said something that's not true, and I keep on going, and maybe I speed up, or maybe my tone changes, or who knows what. It's differently depending on what kind of lie it is. But the thing is, the function of fatwa within the apostasy domain is that once you've inserted this thing that's wrong, you're going to be accelerated away. So we can think of it kind of like alcoholism, which I would like to hope RMS and Larry Wall and Andrew Clapper, people in this industry who are interested in what free software is and how do we put something out there that other people will use at all. Like in my case, I've released enough and gotten no response at all. Like I've never dived into a community, but I've been involved with the Debian since 1998, 1997, long time. For some people who are outcasts for whatever reason, like somebody's already operating on this channel, and so adding something to it creates noise. I worked at Bonneville Power for 6 years, which is where I think Bill Gates got his start. And their Army Corps of Engineers, they come out of the original building of the Hoover Dam. What they essentially are is a legal operation. So with the building of the Hoover Dam, this is the single construction project of history as far as the definition of construction is concerned. They targeted power delivery. And they reached a certain goal with that. And they're kind of maintaining it there. And so if you're in a company like that, where they've already got their goal locked down, and say you want to add new code, how do you do that? How do you actually create this new foundation? Like say I don't want to jump into Microsoft Silverlight and lead on whatever bleeding edge that they're just doing with jargon to stay in the community and keep the business aspect afloat without any actual business doing. But instead, we want to change the industry. I think we all want to change the industry. So for the last, I guess to give how I got here, how I got through Moxie Marlinspike, he had a DEF CON presentation, and we share a common ancestor. So I can sort of call on that person and get what I want out of them, which is pretty cool. So I recognized this actual delivery. It was delivered to the nuclear industry. It's currently powering a keygen and serial number system. If you want to drop in keygen and serial number system for Perl, I can help you with that going in a matter of hours. If anybody is interested, my email is out there. So that's, I guess, the next little point here. If we want to change the industry right now, and we look at, say, Microsoft, what do they have locked down? Why do they control the industry? So for one thing, they have ISA. You can't even speak ISA without Microsoft invocation. In addition to that, they have licenses. So theoretically, what is a license? If, in this case, I don't know if you can read the top line there, this software is released under Sharia law, I will stand by it. If that math is wrong, I will suffer. It's a lot different than the EULA license, where the end user suffers. And so, if we preempt every license in the world, which I'd like to argue that's already done, we now have a new foundational groundwork on which to think about something like Free Software Foundation, GPL license. I don't know if you've ever heard anyone say GPL is cancer. If you know what auto-da-fe is, it in fact is. If you get GPL all over your genome, it's really bad. If we think about what the free software part of it is, and we think about an actual like real license, like a license that supports the cone snail, in my case, that's the target. Like, you want to be able to eat the cone snail. How do you get licensed to do that? It's essentially the same with anything. How do you get licensed to be able to drink a beer in Belgium? Is it a certain age? Do you have to just chug it down and then you're on your way? So if what we have here is a licensed version of the Fukushima reactor, can it melt down? What is a meltdown in this case? If in their version it got too much or too little power and things got overheated and then there was a fracture and spews out all over the place. If they had defined alpha particles properly, I'd like to argue that that wouldn't have happened because they wouldn't have done it in the first place. If I can make an additional argument, if we think about control rods, or the word rods, which I think Microsoft Bill Gates is actively trying to win, how do you win at rods? It's a Scientology question. That's what Scientology is about. You want to win the word, and then you can use it as if you own it. So if let's imagine, for example, that we want to build a nuclear reactor with 137 control rods. Why would or wouldn't that be okay? What's the 137th integral? If we're looking at this model of math and we're following Cesar Arzola's function, which is intended only to identify whether the student is greater than the teacher, then we can use simply how does our communication land in the room. And we can use this model to think about the actual physical interactions. Like, say we end this lecture and I offer time for questions and we get 2 hands raised simultaneously. And these people are interacting off of one another. One of them's chosen first, but the other's listening about their own question while the first person is getting their answer and their question communicated. The actual Fukushima idea is, in a nuclear sense, we have these 2 peers who are active listeners of a communication, and in this electronic nuclear sense, like I don't know necessarily if they had an idea of the signal goes in one way and it comes out like one atom of uranium on the other side is 2 alpha particles. I don't think that that's really possible. So a question like that, if we think about, we have video and audio going on right now. We have people watching in the future, but it's also the present. And so, non-opfer. How much time are we consuming right here? What is this time worth? In my case, I kind of prefer just like the silence of hearing things go the right way rather than dialogue. If we think about dialogue, we have phi and zeta. That's Ecuador. So, given Ecuador, given I've challenged Donald Knuth, I don't know if anybody necessarily realizes that Donald Knuth and I also have a common ancestor, Squanto. I don't think anybody should be Squanto. I don't know if that can get resolved here, but we've broken the nuclear industry. Any questions?
How serious is this talk?
Is there an answer, or that's all I got? Thanks. I think that went well.
Technology is always bounced a couple of times. Right, that's that ready for next. Very much. Yes, yeah. Really? Yeah.
No Japanese.
Previous, Let's tangle them in the bag.
Generally used to having things attached.
No worries. Oh, they're on your back pocket, I think. There's one. Two. Thank you very much. Ooh. I'll break the cable.
Thank you, James.
Oh, yeah.
See you. Thank you.
Thank you.
You ready to be set up?
Oh, the wiring in.
Yeah, wired in. We've got 7 minutes, so we've got plenty of time. Where's the yours is on this side as well? Or is oh
Oh, I got
you
one
do
on
it?
each side. Yeah.
Even better. At which point we should just right. Yeah, so right. Do you want to pop? Oh, wait. I was gonna say, pop that one on. I need to go get a spare battery. Oh.
I wish I had a podium.
FOSDEM. You can put a here, but it will be kind of weird.
Okay. All right, number 2.
The rule is change the battery every 2 hours because sod it, let's not have it dying in the middle of the talk. I've already had the off switch be accidentally pressed. So.
Okay, let's see. We're gonna put this right next to this one, I guess.
Yep.
Or something. Okay.
Good, that's what's recording. So you can, well, we've got 5 minutes.
Can I start early? Because I am.
This one in your back, the wire. The wires look kind of weird.
What should I do?
Tuck it in your pocket. Yeah.
Oh, thank you.
Give him a little bit more around the front, otherwise it'll
All
probably.
right. I may go a little over time. Can I start a little early, or is that well the video not?
I have no idea about theirs.
We can edit manually if you want.
Okay. Well, maybe. Oh, I was gonna put a little timer on. Actually, let's do that.
Because they tag it automatically.
Okay.
So we may be able to.
You can drag it a little, right?
You can change manually afterwards.
Okay, so if we do start slightly early, I can probably.
It's
go say we're starting
2:56.
this talk early because
Got some extra time?
All right.
Yeah, I don't mind. If you want me to wait for people to arrive or anything, or
well, that's the one
No.
thing. That 2 minutes time people may arrive.
oh, that's okay. They'll still get enough out of it even if they come in the middle. I think.
If you want to start early, I'll just let them know.
Okay, let me find have a timer
That one's
after.
still good.
Okay. Okay. All right, I'm going to go ahead and start a few minutes early here, since I have 2 minutes. Hey. And I timed the talk, and it was 42 minutes, so I think I'm in perfect shape. My name is Brian Duggan, and I'm going to talk about Perl 6 on Jupyter. I want to do a little poll first. How many people have heard of Jupyter notebooks, or IPython notebooks, or similar things? Okay, about 50-50. Good. And how many people use Perl 6? Or know something about it, or okay, also okay, good. Okay, so my name is Brian Duggan. I'm here from the U.S., from Philadelphia. I work for a company called PromptWorks. We're a consulting company. We do projects in a variety of languages: Perl, Python, Ruby, JavaScript, Elixir, Go. We're a polyglot organization. This is an outline of my talk. So I'm going to start off with a little introduction about Jupyter, the Jupyter system, notebooks, and the console client, some of the architecture for Jupyter, what's it all about. And then I'm going to talk about some of the specifics of the Perl 6 kernel that I've been working on, including auto-completion. And then I'll get into, after talking about the console, I'll talk about notebooks. I'll talk about magics, which are they're sort of like macros in a way. They kind of transform the input or the output of different notebook cells. And then I'll go into some more clever things like comms, which are ways of doing asynchronous communication between the notebook and the server. And then finally, I'll go through a sort of a fancier notebook example and show you how to put some of these different features together. But first, if you have a laptop, you can play with Jupyter Notebooks while I'm giving this talk. If you are looking at your laptop anyway and want something to do, you can go to this URL, which is also linked in the schedule. This is the Git repository for the kernel, github/bduggan/p6-jupyter-kernel. And you'll see a button there that says Launch Binder. That links to a site called mybinder.org. And when you click that, it'll automatically spawn your very own Docker container that's running Perl 6 and interacting with a web Jupyter notebook. Okay, so a little bit about Jupyter. So Jupyter started off as it was called IPython at first. And the goal of the project was sort of to take people who were familiar with